On this video, we will go over how to follow any line using the color sensor provided at the kit. So the first thing we have to do is open Lego Mindstorms EV3, start a new project. Go right here, top left, click the plus sign, and there we go. So the first thing we have to do is go on flow control and grab a loop. Next thing we have to do is get the color sensor. So right where sensor is on the tab, go straight to the color sensor. After this, we have to get the math block. Now, the reason we have to get a math block is because we have to convert the information from our color sensor with the math block so that our next block, which is the movement block, so that the color sensor can be converted so that the movement block can actually read it. So now the next thing we have to do is change the settings for each one of these blocks. So the first thing we have to do is open up and change what the color sensor should measure. Okay, so we're going right here, measure, and instead of color, we are changing the reflective light intensity. The reason for this is we get a better accurate reading from the sensor than any other setting it has. Now after this, we go on to move to the math block. Now the math block, we have to create a simple equation in order to convert the information from the color sensor to the math movement block. So the first thing we have to do again is go right here and change it from add to advanced, and it's going to give us more variables and freedom to actually create our own equation. So for this math block, we're going to use this very simple equation. So we go parentheses a minus b times c. Now I left d out of the math equation because for right now we do not need this. Now the next thing we have to do is change the settings for the movement block. Now right now it's set on for rotations. For this program we needed to have it on. That's all we have to do. Now the next thing we have to do for our program to actually work properly is link all these three blocks together. So the first block, the sensor block, would go on variable A, and then the result for this equation would go on the steering. Now if we look at the steering, it's going to give us a range of numbers from 0, meaning straight, to 100, which is right turn or a very sharp right turn, all the way to negative 100, which is a very sharp left turn. Now for the purpose of this, we have to go straight. So whenever we put our robot straight, so whenever we put our robot whenever the robot is following the line, or whenever you're starting to follow the line, we want to make sure that our sensor is around 2 to 1 centimeter off the ground, and measure the light reflectancy between the two colors or that is following, which is the color of the line and the color of the background where the line is located. So now that we know that 0 is straight, we can figure out our equation, which is the same exact thing we go and link up this movement block straight to our steering column right here, and we leave the power for right now 75%. So now the math block that we have right here, we're gonna have to change our variables. Now we have A, B, and C as our variable. A, which is a color sensor, so whatever it measures on the robot, it will go straight from here into our variable A. Now B has to be equal to the same amount of light reflected on the robot, on the line between the edge of the tape or the edge of the line, whichever one you're doing. For this is all based on your robot, how you build it, and the light environment around your robot. So the first thing we have to do is state the light reflectancy, which on my robot, on the one I built just for this program, it is around 32.8. Now the reason I got a decimal is because I'm using a color sensor that is not part of the EV3 kit. I'm using the NXT 1.0, which is one of the first kits many years ago. Anyways, we have our number right here, 32.8. If we look at our equation, it's going to tell us A minus B. So A minus B, which A should be around 32.8, meaning is equal to 0. And then C, for right now, we have it equal to 0. If we leave it like this, our whole answer is going to be 0, and your robot's going to keep going forward forever, even though it's on the line. C, in this equation and in this programming, C is a multiplier, meaning whatever answer I get from A and B is going to have to be multiplied with C. C is also used to make sharper turns. So it's always a good start to go from 1 and then 2, 3, 4 until you have the right consistency for your robot. If it's turning too sharp, if it's turning too wide, it all depends on your robot. For my robot, I've done this before, which is around 3.5. Okay? And that's pretty much it. Okay? This is how you make a robot follow a line. Now remember, we have to change the ports. So for my robot, we have to change port to number 4 from 3 to 4, which is 3 is standard for the programming. And my ports for left and right, B and C, D, my robot is D is on the left, and then A is on the right. If we plug in our robot to our computer, we can get the exact reading from the color sensor to our computer. Now there's also another way to find how much light reflectancy is on the line you're trying to follow, or any color. There's 2 ways. The first way I'm doing it is with the computer, so you guys can actually see what I'm looking at right now. So right now, the table that I'm currently on is a white table, and if you guys look right here on the right bottom corner, you're gonna see a whole bunch of blocks. Now these blocks are the inputs for your robot. We have input A, B, C, D, and input 1, 2, 3, 4. A and B and C and D are for motors. 1, 2, 3, 4 are for your sensors. So like I said before, if you do have an EV3 sensor and you're currently using that on your robot, just one sensor, this number right here, we see right here on input 4, it's going to read out a whole number. As of right now, like I said before at the beginning of the video, I have an EV Mindstorm Lego 1.0 NXT 1.0 sensor, which will give out a more accurate reading, as you guys can see, but it does fluctuate between 47.28 to 47.15, which is very inconsistent. Okay, so now that we have this, we can download it straight to our robot and then test it out.